Okay, so what we're doing is we're trying to find points of intersection between graphs. And we've got three examples there. We have a quadratic intersecting a line. So if we have a quadratic and the equation of a line, there could be no points of intersection. There could be one point of intersection when it touches it. All right, now the word we use to describe that is tangent. It's tangent to the curve. That will pop up. Or the line could cross it twice. Okay, those are the only three options. It will either be no solutions, one solution, or two solutions. Okay, so let's get straight into our example here. We have the function x squared, take 5x plus 6, and we have the function 2x take 4. And we want to know, when do they meet? When do they intersect each other? Now the algebra that we're going to perform in a moment is this. We're going to go, when does x squared take 5x plus 6 equal 2x take 4? Because if they're equal, the coordinates on the left-hand side are the same as the coordinates of the equation on the right-hand side. So let's do it using our calculator to refamiliarize ourselves with those skills, and we'll look at two approaches because our calculator is our friend, so we want to use it as best as we can. We're going to go to graph mode, all right, and we're going to sketch both functions. So we've got y1 in the first function, we'll sketch this one, x squared take 5x plus 6, and in the second space we're going to sketch this function, 2x take 4. Over a standard V window, so we're pretty familiar with setting our V window to standard now, hopefully. And what it's going to pop up with, it'll give us a graph that looks a little bit like this. All right, and then there's an equation of a line here. Okay, who's got issues? Alright, very good. So, all we're asked to, if we're finding when they intersect, we're going to press G-solve and intersection. So G-solve is on F5, Lincoln. G-solve is F5, and intersection also corresponds with F5. And it will bring up the first coordinate. We can see x is 2, y is 0. And it will bring up, if we use the directional pad, we can navigate to the second coordinate. X is 5, y is 6. So whenever we're finding points of intersection between functions, that's going to be the best way to do it. Okay, let's look at how we can use an algebraic approach. So this here is a quadratic equation, and we're going to solve it. What we're going to do, like we would normally solve a quadratic equation, is move all of the terms to the left. So I'm going to move this line over here. I'll just do it a long way first. We're going to take away 2x from both sides. So we've got minus 2x over here, and we're going to plus 4 to both sides. All right, because that's going to cancel all of the terms on this side, isn't it? So we have a plus 4 there. So we're moving it all over to the left-hand side. We'll collect all of our like terms. So we would have x squared, we have minus 5x, and then take away 2x. That's going to be take away 7x, and positive 6 and positive 4 together combine to give us positive 10. Okay, so then we're going to try and solve this quadratic. Now from here, basically, we have three processes that we've learned to solve this quadratic. We can factorize it using the cross method. We can factorize it by completing the square, or we can use quadratic formula. It's really up to you now. Now that you know all those three processes, it doesn't matter which one you apply, you go your hardest. I think factorization is going to be the easiest for this quadratic, but it will vary depending on the quadratic. Alright, so we're looking for two numbers that multiply together to give us positive 10. And when we add them together, we get minus 7. This will, of course, be negative 5 and negative 2. Alright, minus 5 times negative 2 gives us positive 10. And when we add those together, we get negative 7. Apply the null factor law. We have x is 2 or x is 5. Those are our two solutions. Now, we're asked for the coordinates, which means we've got an x value, we need the corresponding y value. Now, we can put these x values into either of these equations. They are both going to have the same y coordinate. Why? Because that's where they meet. Of course they're going to have the same coordinate. So it's definitely going to be easier to substitute into here. There's much less to process, right? So if we find g of 2, we've seen that notation in our first topic. G of 2 means we put the number 2 into the g of x function. We're saying when x is 2, what's the y value of this function? 2 times 2 take away 4, it is 0. And that was the coordinate that we g-solved, right? When x is 2, y is 0. All right, we'll put in x is 5 into the g of x function. We'll find g of 5. That's going to be 2 times 5 take 4. 10 take 4, 6. All right, which is also what we g-solved. So these functions meet at x is 5, y is 6, and at x is 2, y is 0. Those are the coordinates of intersection. Now, we won't go through the second example just yet because that's a more abstract example. We'll go through it in a bit of a moment. So, we're asked, given x squared take 2x take 3, and the function mx take 7, find the value of m such that there's one solution. So let me show you what I mean by multiple solutions. So I've sketched here, I've got both graphs, and this is something I can do in Desmos. You can't do it on your graphics calculator. But what we've done is we've got the quadratic there, and then I've got mx take 7 where I've got changing values of m. Now we saw this when we were doing exercise 3F, right? We added these sliders in, and we can see that I can now drag this value and it changes the slope of the line. Because look, this is the equation of a line, y equals mx plus c, has a y-intercept minus 7, the slope of m. And so all we're doing is changing the value of m. We're changing the value of m until there is, look, at the moment there's two solutions, all right? It intersects it twice. If we decrease the value of m, we'll see that there are no solutions because it doesn't touch. We want to find what's the value of m when there is one solution. So we could fiddle around on Desmos and get a trial and error approach and see that it occurs when m is 2, all right? But let's look at the algebraic approach now. So that's what's going on here. That's how we're finding that solution. So we have this quadratic x squared take 2x take 3 and mx take 7. We're going to start the same way where we equate them. So this is example 2 in our notebooks. And then we're going to move everything to the left-hand side, right? So I'm going to move both of those terms over here. Now, I'm going to write the two x terms next to each other because we have minus 2x and take mx. So I'm going to put those next to each other. So what we have is x squared take 2x take mx. And then we have minus 3 and plus 7. If I have minus 3 plus 7, positive 4. Okay, so then I'm going to look at these and I'm going to go, well, what's common to both of those? We can see that x is common, right? X is common to both of these terms. So I'm just going to factorize it from there. I've got, I'm going to have 2 take m, and then how can we do it? We can maybe, what's the clearest way? Maybe like this, if we have plus x times minus 2 take m. Okay, I've factorized positive x. Okay, what this means is the coefficient of x, the number in front of x is this term here, and then we have plus 4 equals to 0. All right, so this is a quadratic here. It's a quadratic equation, but we've got another variable in here. We've got m. Now, here's the connection we're going to make with the discriminant. We want one solution. We want to know when it is tangent to the curve. Now, remember from the discriminant of a quadratic will be positive if there are two solutions. It will equal 0 if there is one solution, and it will be less than 0 if there are no solutions. Now, we want one solution. So we want to know what's the value of m when the discriminant equals 0. That's the further part that we're going to now do. So the discriminant is b squared take 4ac. That's the discriminant. It's the inside of the quadratic formula. So we're going to solve the discriminant here and make it equal to 0. So our discriminant then is, we've got to identify the values of a, b, and c. So we've got a, b, and c. Okay, they're the coefficient of the x squared term, the coefficient of the x term, and then the c term. And we're now going to do b squared. So I have minus 2 take m squared, take away 4 times a times c. All right. So when we perform this square here, it's a little bit tricky, but basically everything's going to be positive. We're going to have 4 plus, so we have 2, let's do it slowly, sorry. We have minus 2a squared plus 2 lots of a times b plus b squared. And it will all be positive. Why am I rubbing that out? Because we have the 2 negatives in brackets, both of them are negative and we're squaring it. Like another way that could be written, this is why it's all going to be positive, I'll show you. We have minus 2 take m. We could write that as minus 1 times 2 plus m. Okay, that we can factorize minus 1, and minus 1 squared is positive 1. Okay, so all of the terms are going to be positive, and then we have take 16 over here. That's our discriminant, and we're finding when the discriminant is equal to 0. All right, because when it's equal to 0, we have one solution. So let's process this. We're going to have positive 4 plus 4m plus m squared take 16. All right, we'll start to collect like terms and present this as a quadratic. We're going to have m squared plus 4m take 12. All right, and so then we're going to factorize this quadratic, 2 numbers that multiply together to give us minus 12. And when we add them together, we get positive 4. So that's going to be positive 6 and negative 2. Apply our null factor law. So we have 2 values of m. Now I'm going to take you back over here and show you why both of those are solutions. So we can, maybe I'll get rid of the slider. And if I sketch, if we have m is 2, if I sketch 2x take 7, all right, we can see one solution. That's where it touches the curve once. All right, so we're saying what are the values of m for when there's one solution? Well, it's when m is 2. And the other solution that we have is m is minus 6. All right, and when m is minus 6, we also have one solution up here somewhere. In there somewhere, we can zoom in if you want to see it, but there's one solution. All right, where it touches the curve once. Okay, so what we're doing here then is we'll start by equating them. We move everything to the left-hand side just like we were doing, but the trick now is we need to either collect the b term or the c term. Bring them close together, there'll be some variable. All right, bring them together, and then we find the discriminant and make it equal to 0 because we're finding one solution. And then we solve for that value of m that makes that true. Okay? So your first example, they have 3x plus c. That's in question 2. Let's move on, have a go. I can offer a few prompts if we're finding it a bit challenging.